This is problem 1.4.1d. So we're supposed to find the probability of B given A union B. Now it doesn't say this specifically, but this A union B, that part's kind of supposed to happen together. Okay, so this is saying what's the probability that B happens if you know that A or B has already happened. So I'm going to write that out into words. Okay, so it's what's the probability that B happens if you already know that A or B has happened. So it's saying either A or B has already happened. What's the probability that it was B? Okay. Or I'm kind of putting here happens, but everything is, we're kind of assuming it all happens at the same time. So if we know that either A or B has happened, what's the probability that it was B? So when you look at this, all the symbols might throw you. I might change these to words. Not the conditional symbol because I usually don't do that, but we'll do probability of B given this is A or B. Sometimes it's easier with ors than symbols. This is your union symbol, it means or. Now to figure this out, we'll use our conditional probability formula. So we'll do the probability of what comes first on top, okay, with an and. We do the intersection of what came second. So it'll be B and, we'll do parentheses, A or B. All over the probability of what came second here. So the probability of A or B. Now this part, we don't have formulas to figure out what happens here on the top. You have to use logic on this. So what's the probability that, or if you're thinking of the intersection, what would it be for B and A or B? So A or B would be everything in here, A or B, but you have to intersect that with just B. So the intersection of just B, well, what do you have left? You just have B. So if you have B and A or B, the only place where that and can happen, that they're both happening, is in B. So this just equals the probability of B over probability of A or B. Okay. So you have to come up here and look at all of these probabilities. Fortunately, it's kind of hard to see these now. So for probability of B, find all of these probabilities in B and add them up. So 0.08, 0.13, 0.06, 0.01, 0.02, 0.05, I think 0.11. Add all those up and you're going to get 0.46. Then for probability of A or B, you'll include all the ones in B and all the ones in A. Okay, so if I do A first, if I include everything in A, that will be 0.32. Plus then I do everything in B, which is everything over here, which is 0.46. But you'll notice that actually included this middle twice, so we need to subtract everything in the middle out. So minus 0.08. And this gives me 0.657. So really the biggest thing here is that they made it more complicated when they said B given this A or B. So it's like you have to put little parentheses around the A or B and carry those parentheses all the way through. So it'll be A or B, A or B, A or B. So you take that whole chunk and put it in every time you need it in the formula.